All right, this is video 3 of section 1.2.1. Our topic is justified line and angle relationships. Our specific learning target is I can apply the linear pair postulate and vertical angles theorem to find missing angle measures. So here's our first example. It's determine all 4 missing angle measures and provide justification for your process. You must read the directions. Sometimes they'll say, what's the value of x? And you just have to find x. Other times it might say, find the measure of angle ABE. All right, you got to find this angle. So you're going to have to figure out what are these angles values and then figure this angle out using the different relationships. So in this example, we're just going to find all 4. All right, so the first thing we're going to start with is we have these 2 angles are given. And we got to ask ourselves, what is the relationship between those angles so we can write an algebraic equation to solve for x. So if I look at the 2 angles, they're along a straight line, they're adjacent, right next to each other. I know that those are a linear pair, and so we know from the linear pair postulate that means these 2 angles are supplementary. Again, supplementary angles, 2 angles that add up to 180 degrees. All right, so we're going to use that to write the equation. So we're going to say 12x plus 20 plus 3x plus 10 equals 180 degrees. We're going to solve this, so I'm going to combine like terms. 15x plus 30 equals 180. I'm going to use the subtraction property of equality, subtract 30 from both sides. 15x equals 150. I'm going to use the division property of equality and divide both sides by 15 and get x equals 10. All right, but we want to find the measure of all 4 missing angles, right? So 10 is not the measure of the angles. If we take the 10, we're going to substitute it for x to figure out what the measures of the angles are. So if I plug in 10 for here, I go 12 times 10, 120, plus 20. This angle is 140 degrees. So we can say that the measure of angle EBC equals 140. Okay? Then, the measure of this angle here is take the 10, substitute it in for x. 3 times 10 is 30. 30 plus 10 is 40 degrees. So we can say the measure of angle CBD equals 40 degrees. All right. Sometimes they might ask you to find these angles here when there's nothing there. It's just blank. That's okay. We know the relationship here. So if I want to, I could use the vertical angles theorem. So the vertical angles theorem, which says that vertical angles are always congruent. And so we know that this angle here and the angle above are vertical angles, are the ones opposite each other, not adjacent. So if this is 140, we know that this is 140. And we could do the same thing here. This is vertical with this angle here. Since this is 40, this is going to be 40. Since they're congruent angles and all congruent angles have the same measure. So we can write that down. The measure of angle ABD equals 140. And the measure of angle ABE equals 40. Now, I want to be crystal clear here. The way we set the equation is not always the same. It's all based on the relationship of the angles that are given. A lot of students in IM2 in the beginning will make mistakes where they just kind of memorize this process and they want to do this everything. Everything always adds up to 180. Or the next process we're going to do, they always want to do that versus thinking about the relationship with the angles. So let's do another example. Example 2. All right, we want to determine all 4 angles here. So this time I'm given 2 angles, but is this a linear pair? No, it's not a linear pair. These are vertical angles. So we're going to use the vertical angle theorem, which says that the angles are congruent. Therefore, we know that the angles measures are the same. So to set this equation, it's going to be simply 16x minus 30 equals 11x plus 20. Do you see the difference? It's based on the angle relationship. Vertical angles are congruent. All right, so now we solve the algebra. We subtract 11x from both sides, and we get what, 5x, and we add 30 to both sides, so we get 50. We divide both sides by 5, division property of equality, so we get x equals 10. All right, so now we find those measures of these angles. We substitute 10 for x, so 11 times 10 is 110, plus 20 is 130. If I decide I want to substitute into this x, 16 times 10 is 160. 160 minus 30 is also 130. So that's a nice little check. If you're on a big test, you can substitute for both, make sure it does work. If it didn't, that means we made an error here. Or we made an error in how we set it up. Right? So let's write those down. So we know the measure of angle JKL equals 130. The measure of angle NKM equals 130. All right, so now we need to figure out these two angles. Well, they are vertical, but there's nothing for us to use to try to figure those out with just the vertical angle relationship. So what we're going to do is, wait a minute. Aren't these two angles actually a linear pair? That's right, they're a linear pair. So that means they're supplementary. So if this is 130, how are we going to figure out this angle? That's right, supplementary is two angles added to 180. So we're going to go 180 degrees minus 130, and we get 50 degrees. This is 50 degrees. We can do the same thing on this side, or once we figure out that's 50, these are vertical, so they have to be congruent. Measures are the same, so then this is 50 as well. So we'd say that the measure of angle JKN equals 50 degrees, and the measure of angle LKM equals 50 degrees. That's it. That should be the end of your 1.2.1 notes. Thank you.